A very good morning, dear my students. In previous lecture we were discussing about the atomic radius, and already I have said that the distance between nucleus and outermost cell of atom, that is called atomic radius. And also one thing I have discussed, it is very difficult to find out the atomic radius because electrons have both character, particles character as well as they have a wave character, means they will move like a wave, and in that condition we cannot measure the atomic radius. And how we can measure? When two atoms combine to form covalent bond, and in that condition we can find out the atomic radius. Because in your book starting month it is given, suppose it is a nucleus and electrons are revolving around the nucleus. Suppose electrons are there, so you can say that the distance between the nucleus and outermost electron, means the valence electron, that is known as a atomic radius. Okay, it is a right, but in a higher section and little bit about this one it is given in your book. Electrons have both character, and electrons revolve around the nucleus as a wave, because it has both character, particles as well as a wave character. Then that time it will move. Then how can you measure the atomic radius? In this condition you can measure the radius when two atoms. And what is a covalent bond? The bond is formed by the sharing of electron. I think we have discussed in the 9th class. When the bond is formed by the sharing of electron, it is called covalent bond, and the compound which form, that is called covalent compound. So in the case of covalent compound, actually there are lots of radius, but in 10th class there is no need to know van der Waals radius, ionic radius and metallic radius. Just know about the covalent radius. Suppose two similar atoms, suppose atom A and atom A, both are same, that's why I have written AA. You can give the example H plus H. When both combine, what will form? H2 form. H2 is the molecule, and this is the example of covalent bond because they combine with the sharing of electron. And in this condition you can measure the atomic radius. How? Simply take the distance between the center of first atom to center of second atom, and then you will find out the radius is equal to distance between A and just divide by 2, then you will get the atomic radius. This is a formula to find out the atomic radius, but in your examination it will be written what is the atomic radius. Just you will say that the distance between the nucleus and outermost cell, the electron are present, that is called atomic radius, means valence electron. It is very clear what is the atomic radius. And also I said that it is difficult to find out the whenever two atoms combine to form the molecule, covalent molecule. In that condition you can find out the atomic radius by formula R equal to BAA by 2. It is a very easy one. Now one thing also I have discussed about the cell. I said, suppose this is a nucleus and there is a cell. This is known as orbit. I said in a previous lecture this is called orbit, and the part of orbit is called suborbit. The part of orbit is called suborbit. And how many suborbits are there? S P, D and F. I said that. And also I said in a first cell only S is there, in second cell S and P, in third cell S, P, D and fourth cell S, P, D and F. And how many electrons are there in each, in particular subcell, in particular orbitals, you can see very well. Already I have given you. S has one room and one room can have only 2 electrons. P have 3 room, it can have 6 electrons. So already you have discussed in the previous lecture what is the electronic configuration, how to find out. Suppose I write in the case of, I am giving you example in the case of SPDF electronic configuration. Suppose I am giving you example sodium 11, its atomic number is 11. In 10th class, in 9th class, simply you will write 281. Simply you will write 281. Means N has 3 cell. First cell, K cell, L cell, M cell. K, L, M cell, only it has 3 cell. So how can you write the electronic configuration in the case of, in the form of SPDF? So already I discussed in the first cell can have only one suborbit, just write 1s. Why I am writing 1s? Because it 1 represents the first cell. The first cell, yani S can have how many electrons? S can have only 2 electrons. This electron will go there. And second can have 2 suborbit S and P. So you can write 2s and 2p. 2s and 2p. Then this 8 electron will distributed among this cells. So S can get only 2 electrons and P can get 6 electrons. And last one they have SPDF, but you will write 3s only because it has only 1 electron and 1 electron will go in 3s. And you can see that this is the first cell, you have written 2, these both are second cell, you have written 2 and 6, 8. And last one it has only 1 electron, it will go in S suborbital and it is written 1. So simply you can write 2, 8, 1. This is the first cell, this is the second cell, this is the third cell. Of magnesium, what is the atomic number of magnesium? 12, and you will write configuration 2, 8, 2 in the case of whatever you have discussed in 9th class, in 10th class also. But in the case of SPDF form, we know that 1s, because it represents the first cell, 2 electron will be there. Then second S, 2s, 2p. And you can see that 2, 6, 8 and 2, 10. 8 to 10. Just this is the second cell, this is the first cell. And then last cell you will see that only 2 electrons are there. So already we have discussed in third cell what is there? SPD. All these cells, subcells are there, but only 2 electrons are there. The 2 electrons will go in 3s2 only and 3p will be vacant. So there is no need to write the p. Simply we will write 1s2, 2s2, 2p6, 3s2. This is the way to write the electronic configuration in the form of suborbit SPDF form. You will study about it in 11th class only. It is not given in your book. But why I am making you understand, always it is asked in your examination. Suppose number 15 will be given and you have to find out it belongs to which group, what the property it has. So first you will understand that SPDF, then you will be easily to find out the period, groups, metallic and non-metallic character. So now next topic, again I am going to one more example. Suppose I will write the aluminium. Aluminium, it is a 13. So what is the electronic configuration according to yours? 283. First cell K, L, M and N so on. That is a cell. But in the case of suborbit, you will write K means first cell. First cell can have only one subcell, that is 1s, and 2 electrons will go in 1s. And then L cell means second cell, and second cell have how many subcell? S and P. So you will write 2s and 2p. And already we have discussed S have one room and it can accommodate only 2 electrons. So 2 electrons will be there, and then 6, 2, 6, 8 to 10, and then 3s and 3p. You can write that, and you can see that S can have only 2 electrons. Then how many electrons left? Only 1. So 1 electron will go in here, and you can see that first cell represent 2, second cell 2s 2p, second cell 6 to 8, and third cell 3s2 and 3p1 2 1 3. Just the way to write the electronic configuration in the way of suborbit. It is a very easiest form, and please, it's my humble request, note down in your copy. I swear it will help you out in your examination. Now next, so we have discussed about the atomic number, atomic radius and electronic configuration in the form of SPDF. But one thing is that in the case of potassium and calcium, 19 and 28, just you are writing 2881 and 2882, just you are writing this way. Why you are writing? Because you know that 2n square only formula, and first cell can have 2 electrons, second cell can have 8, third cell can have 18, and fourth cell can have 32. Means first cell is okay, 2, second cell is okay, but third cell here 18 is showing by the formula, and you are writing third cell means 8 and fourth cell is 2. Why it is possible? You will get confused now. Why we are writing in the case of 8 and 1, 8, 2? We must write now here 10, and after the filling the 18 electrons, next electron will go in fourth cell. But we are writing this one. Why? What is the reason? Actually, teacher used to say that in a 10th class, you just learn it in the case of potassium and calcium. But why it is happening? The main reason is that, listen, suppose in the case of potassium, first cell 1s, it has 4 cell now, 1s, 2s, 2p, sorry, first cell, second cell, third cell and fourth cell, 1s, 2s, 2p, this is for second cell, this is for first cell, 3s, 3p and 3d, it represents the third cell, because third cell have 3 subcell, and fourth cell have 4s and 4p and so on. No problem is that I am not writing, because there is no need to know about the fourth D and F. Just learn, in the first cell it has 2 electrons, it will go in S. Second cell it has 8 electron, 2 and 6. The first cell 2, second cell is 8. It is right. But in the case of this one, first electron will go in 2s and 2p and 6p, 6 to 8. Then remaining electron must be go in D. But one thing, just note down by putting the star, the energy of D is the more than energy of S. Energy of D is the more than energy of S. So electron first will go in S orbital. Electron will go in first S orbit compared to D, because the reason is that, just note down, why electrons are moving from 3p to 4s, it is not going to 3d, because of 4s has less energy than 3d, and electron will go in that place only where energy is less. That's why remaining electron is that 1, 2, 8, 10 and 18, you have only 1 electron. 1 electron will not go in D block, only it will go in S, and that's why you are writing 2881. You are not writing 288 and 9. Why you are not writing? Because of this reason, because the 3d orbital has a more energy than the s, and electron will go in the less energy suborbit compared to more energy suborbit. It is clear? Similarly, in the case of calcium, first cell 1s2, 2s2, 2p6, 3s2, 3p6, and 3d is there, but 4s, first electron will go in 4s, not the 3d, because the s has less energy than the d block, and therefore electron will go in that place only where energy is less, and you can write that 2 first cell, second cell is 8, third cell is 8, and fourth cell is a 2, and this is the reason you are writing the electron configuration 2881 and 288 and 2. Now first group, hydrogen, lithium, sodium, potassium. So what is the atomic number of sodium hydrogen is that 1, lithium 3, sodium 11, potassium 19. Simple is that. Also I have given you magic number how to find the atomic number of every element whatever is there in a periodic table. So it is very clear, and just write the configuration 1, 281 and 2881. This is the way to write the electronic configuration. Now one thing is that you can see here, it has only one cell, K cell, it has 2 cell, it has 3 cell, 4 cell. So atomic radius factor on which atomic radius depends. The first factor is that number of shell, and second one is that nuclear charge. Yes, my dear students, it is very important. The atomic radius depends on two factors, number of cell and nuclear charge. And just see here, if I will talk about the hydrogen nucleus, it has only one cell. So I am not talking about hydrogen because hydrogen is a non-metal now, so there is no need to talk about hydrogen. Just talk about lithium, sodium and potassium. So how many cells are there? 2. This is the nucleus, first cell and second cell. It has 2 electrons, 1 and 2, and valence cell is a 1. Again in the case of sodium, first cell, second cell, and it has third cell also. So in a first cell 2 electron, in second cell 8 electron, 1, 2, 3, 4, 5, 6, 7, 8, you can write that, and last cell is the 1. In the case of potassium, you can see that nucleus, first cell, second cell, third cell and fourth cell. Yes, my dear student, you can see that here 2 electrons will be there, here 8, here 1. All they have same valence electron, 1, 1, 1. But what is the difference? Difference is that number of cells are increasing. Here it has only 2 cells. Here has 3 cells and here are 4 cells, 1, 2, 3, 4, and you can see that the distance between nucleus and valence electron here is a bit bigger compared to the sodium and compared to the lithium. Which one has a least distance? In the case of lithium has a least distance, and you know, if they have a least distance between nucleus and valence electron, so valence electron carry negative charge and nucleus carry positive charge, and there is attraction. So small size, greater attractions, and valence electron will be pulled toward the nucleus, and when electron pulled toward the nucleus, size will decrease. And in the case of potassium, you can see that number of cells are increasing, distance is also increasing from the nucleus to the valence electron, and once distance increase, attraction decrease, and when attraction decrease, size will increase. And it is a very clear when we move from group from top to bottom, when we move in group from top to bottom, what will happen? Size increase. It may be asked in an examination, why when we moving in group from top to bottom, size increases? Because of number of cells are increasing from top to bottom, and when cells increase, distance between nucleus and valence electron will increase, attraction decrease, therefore size will increase. Thank you and have a nice day, and I expect that all of you will note down all the important topics. Thank you, have a nice day.